We've been looking at projectile motion, and Kyle, our argument has been that if an object is moving in 2 dimensions, we look at it via components. We look at the vertical and the horizontal motions separately because they are independent of each other. And one of the key ideas we said was horizontally, your horizontal acceleration is 0. Your vertical acceleration is negative 9.8. I called these kind of sarcastically our physics no-brainers. I said those are the first 2 things I write down when you give me a projectile to solve. The rest of it, I'm very meticulous. I make sure that I don't put a horizontal value into a vertical equation or a vertical value into a horizontal equation. My tool for helping that was what I called a T-table, just to really help me keep things straight. And we said there's going to be on your test 3 main questions. The easiest was launching horizontally from a cliff. And the reason that was easier was when we launched horizontally from a cliff, Vy initial was 0. And anytime you get a 0 in your equation, that's good. What did we say you're going to spend most of your time finding? Time, okay? Then the second type of equation I'm going to give you, is being launched from the ground at an angle. Did I say angle? Components, okay? You're going to break it up into horizontal and vertical components. And then just be very, very careful. You know a few things. You know at the top for a split second, Vy is 0, not V total, because there's still a Vx. It's still moving sideways, but Vy is 0. And you can make a few other assumptions like that. The toughest is what we looked at last day, cliff at an angle. And the reason this one is the toughest is to find time, you're going to end up using the quadratic formula. Or there is a clever workaround. If you're shaky on the quadratic formula and you want the workaround, hit me up later on in class or hit me up during a blended block. I almost said flex block. Blended block. Flex block. Remember those? So we looked at a few, and you noticed it took a fair bit of time to find time. Once you had time, though, the question tended to fall apart. So we paused on part C. So here's what we had said. And just pick up where we left off. We had looked at a projectile that was being launched at an angle of 64 degrees above the horizontal, 36 meters per second. Did I say angle? Components. And AX equals 0, AY equals negative 9.8. We had found the range, but first to find the range, the dx, we had found time using the quadratic formula. We had rejected the negative root. C says this, find the velocity at t equals 2.4 seconds. Now, in one way, this is a little bit easier because, when they gave me time. And anytime they give me time, the question's going to fall apart. What does this question want me to find? No, read carefully. What? Velocity. I think the velocity either, don't write this down, looks like that or like that. It could be on the way up, it could be on the way down. Wait a minute. Can you all look at part B? Did we figure out the time to top in part B? Yeah? What was the time to get to the top in part B? How many seconds after launch did it reach the top? Anyone? 3 point? How many seconds in this question? Are we on the way up or on the way down? Okay. Everybody, now we can dollop. I'm going to say the velocity looks like that. It might be steeper. It might be shallower. But Kai, it's something like that. It's at an angle. Oh, did I say angle? We're going to break this up into Vx and Vy final, not initial, because this is Vy later. But Vx, I know from the previous page. Can somebody look at our T-table and tell me what Vx was, please? $15.781, 15.781. And from the previous page, can somebody tell me what Vy initial was? And I know Ay, everybody? And they told me time in this question, 2.4. Hey, I know V initial, time, and acceleration. Is that enough that I can find that and stick it onto my triangle? Yeah. There is an equation that has a V final, a V initial, an A, and a T in it. Yeah, you might want your formula sheet out. Petco, which one? So Vy final equals Vy initial plus Ayt. Yeah. Vy final equals 32.357 plus negative 9.8 times 2.4. Do you get 8.837? Yeah. What if I'd done this calculation and I got 0 as an answer? What would that tell me? If I got exactly 0, what would that tell me? Where is Vy 0? Oh, by a fluke, the time that they gave me, I would just happen to be at the top. Now, I know that's not the case because we did part B already. Ooh, what if I got a negative answer for Vy final? You know what? Tell me I should have drawn it that way, and I would quickly correct my diagram. Or I might even calculate Vy final before I even started. Here, I had the advantage of knowing where the top was from part B, but if they hadn't given me that, I probably would have said, well, why don't I find Vy final, see if it's positive or negative, Jack? I'd like to know, am I on my way up or am I on my way down? How am I going to draw this? But in the meantime, 8.837. And Matt, this is the velocity right they want me to find right there. How can I find the magnitude? I'm looking for a word that starts with the letter P. Pythagoras? Did somebody say parabola? Not that. Pythagoras. And then where am I going to put the theta? Bottom left or top right? Bottom left. Color, 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 color. Okay, let's continue. Opposite, adjacent. Yeah, I got this. I got this. So V is going to be 8.837 squared plus, I could have just hit my answer button, I guess, 15.781 squared square root. It's going to have, whoop, typo, Mr. Dewick. Square root, answer button. Magnitude of 18.1. Double check me, but I think I'm right. Yeah? Which trig function am I going to use to find theta? Okay. Tan theta equals opposite over adjacent. Opposite over adjacent. And I get 29.2 degrees. I'm looking for a typo. Is that right? At 29.2 degrees. North of east? Oh, who remembers what was the notation I introduced to you last class? Do you remember? How we describe from the side view something that's pointing up? We would call this above the horizontal. If it was pointing down, that would be below the horizontal. Again, if you said north of east, I wouldn't mark it wrong, but I'd give you a stink eye, Davis, because up towards my ceiling is not north. Just saying. Okay. Example 4. What if the projectile is launched horizontally from a cliff? Why is this so much easier? What's Vy initial? 0. And that means that you can, when you solve for time, because Vi is 0, you can use physics 11, d equals a half at squared. No need for the quadratic formula. But sadly, that only works for a horizontal projectile launch from a cliff. I will put one of those on your test, but you're going to get cliff at an angle. Example 5. Projectile is launched from a cliff as shown. It lands on the ground 5.2 seconds later. Find the height of the cliff. Find the range dx of the projectile. Do you know why I know this question is going to fall apart? They gave me the time. Usually I spend most of my time finding time. Here, So I'm still going to do a t-table. Armand, is there an angle in this question? Components. Okay, so I'll do all my usual dance, but then I think it's going to be much easier. So here is my Vx. Here is my Vy initial. Why did I put an initial on the Vy and not on the Vx? Well, in my t-table, what are the two physics no-brainers that I can write down? You remember? Yes. Which means that Vx will be constant and it's not going to change. Okay. I gave you a stupid memory trick last class, and I know it's been a couple of days. Jack, do you remember what Vy, which trig function we used to find Vy? Sine goes with Vy. Really? So you're telling me that Vy initial is going to be 20 sine 30, which I think that works out to exactly 10. Double check me, but I'm pretty sure. I know I've memorized sine 30 is 0.5. Do that one enough. Well, Jack, if Vy is sine, which trig function goes with Vx? Of course it does. I know the cosine of 30 is 0.866, so it's going to be 2 times use your calculator, Mr. Duick. 17.32. 1. Yeah? How many things do I know on the right in my vertical column? 2. How many things do I know on my horizontal column? 2. I need 3 to find the fourth. So what else did they tell me? Why is time so nice? Because it's a scalar, it can go in both columns. I know 3 things, I can find a fourth. I know 3 things, I can find a fourth. So A wants me to find the height of the cliff. The word height, what do you think? Vertical or horizontal? Am I finding a dy or a dx? So dy equals question mark. Which equation has a d, a vi, a t, and an a in it? There is one. And you may have noticed that we're frequently using the same equation over and over and over and just tweaking it. Have you noticed it's almost always been d equals vit plus a half at squared? So I'll modify it. dy equals vy initial t plus a half ay t squared. Why didn't I bother putting y's on t? Because time is a scalar. It can go in either, so who cares? Otherwise, it's plug and chug. 10 times 5.2 plus 0.5 times negative 9.8 times 10 squared. Duick, you might be able to do this in your head. 10 squared is 100. Half of 100 is 50. 50 times negative 9.8 is negative 490. 10 times 52 is... I'm doing something wonky. 10 times 5.2. Oh, that I can do in my head. So it's going to be 490, negative 490 plus 52 is going to be negative 400. Is it negative 438? Yeah. Am I wrong? Why did I put a 10 in the t squared when it's a 5.2? That's, my brain was telling me I'd done something wrong and I just couldn't spot it. Thank you. That seemed a little easy. 10 times 5.2 plus 0.5. And you're telling me I got it right? Jeez. Negative 80.5? Is that better? Yeah? Why negative? Is that right, by the way, or am I wrong? I have to better check my work now. VIT plus a half AT squared. That's better. Negative 80.5. Negative because we ended up below from where we started from. Even though I asked for the height, we found a displacement. Technically, height's a scalar, but I don't care if you leave the negative for now. In my answer key, you might see me report this answer as positive because heights are usually measured from the ground up, but there you go. What's B want me to find? I guess the range dx. Hey, that's going to be dx equals vxt. Yes, plus a half AT squared, but horizontally, what's A? 0, okay? And again, I think I mentioned this the other day, but can you see how tempting it would be to put a 9.8 there? Because I don't know the accelerometer, I'm going to put something there. Don't do that. It's going to be 17.321 times 5.2. Oh. 17.321 times 5.2. Y'all get 90.1 meters. That's why I said to you, if they give you time, or once I have time, the question tends to fall apart. So in this case, they gave me the time, made it way, way easier. Ooh. What is the final velocity? Turn the page. What is the final velocity just before impact? Not 0. Looking at this question, when it hits the ground, which way do you think it's traveling? Yeah, I think something like that. Might be steeper, could be shallower, but we're launching from a cliff, so I'm thinking something like that. Is that all right? So I'm going to dulp, I don't know. There's the velocity they want me to find. It's hitting the ground at an angle. Did I say angle? Okay. What was Vx? 17.321? Yeah. Can I show you all a common mistake? Look up for a second. Don't write this down. This Vy is a Vy final, but often I'll see kids put the 10 there, the Vy initial. And then they do the Pythagoras. And you know what they get when they do the Pythagoras? 20. Because that's where those numbers came from. And when they do the shift tan, 30. Because that's where those numbers came from. And they don't realize they've just found the original velocity, but pointing downwards. They found, right when we get back to cliff level, what the velocity is. But we're falling further. So we need to find Vy final. It's not 10. I usually walk over here and just do a short vertical column. Vy initial was 10. Ay was negative 9.8. Oh, I also know time. That was 5.2. I can find Vy final. And Sky, I hope you're noticing now this is exactly the same as the question that we opened up today's lesson with, in that, oh, I think it's going to be Vy final equals Vy initial plus AT. Vy final. Am I expecting a negative or a positive answer for Vy final? I think I'm going to get a negative. I should. 10 plus negative 9.8 times 5.2. And lo and behold, that's 10 times, Mr. Dewick. 10 plus, that seems way too fast. I get negative 40.96. And that's going to go here. I don't need to put the negative on my triangle because the negative is contained in this arrow pointing down. Where's the theta going to go? Top left or bottom right? Color, 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 color. Opposite. Adjacent. Tan theta equals opposite over adjacent. Magnitude, Pythagoras. Geez, Dewick, could you butcher this more? Squared plus 40.96 squared. Square root. Wow. Did I totally wreck that, Mr. Dewick? Let's try that again. Square root, answer button. You get that okay, Jack? Awesome. That's a tough question, asking you to find a slanty velocity. Although I'm also going to argue, I hope, that I technically, Armand, have not taught you anything new the last couple of days. Aside from that the horizontal acceleration is 0, I think everything else is still complicated, but physics 11. I hope. Example 6. What does A want me to find? Alex, what does 6A want me to find? It wants me to find the slanty velocity when they gave me a time. Did we just find the slanty velocity when they gave me a time? And have we done that also earlier? We found the slanty velocity when they gave me a time? Then I'm going to say, I'm going to skip example 6A. And I'm going to skip example 6B. The only thing I would say is I'll bet you 6A is probably on the way up, 4.6 seconds, and I'll bet you 6B is probably on the way down. So when you solve for Vy, you get a negative answer. I'm not going to worry about that. So, extra questions that you can do now. Okay? This is in addition to the ones I already assigned. You can try number 3. I'm just going to add number 3, but Can you get out the ultimate review, that big thick document, please? We're going to cross out some questions. So I'm going to modify this a little bit. So definitely you can try number 1. Circle number 1. 2 is good. 3 is good. I like number 4. I like number 4. Number 4 is a nice question. Skip 5. 6 is good. 7 is good. 8 is good. 9, you can cross out B. Although I've covered finding a velocity with you in today's lesson, I'm not going to throw one on your test, a slanty velocity. I might throw one. I'm going to give you a take-home quiz just after this. I might have put one on there. I can't remember, but we're done the unit. You can cross out 10. 11 is good. 12 is good. 13 is good. 14 is good. 15 is good. 16 is good. I like number 17. I like number 17. I like 17 is good. You can cross out 18. 19 is good. You can cross out 20. 21 is good. 22 is good, but you can cross out B. So 22A. You can cross out 23. 24 is good. 25 is good. 26 is good. 27 is good. You can cross out 28. 29 is good. 30 is good. Oh, 31, they gave me the time. That one's going to fall apart. 31 is good. Cross out 32. And then you'll notice if you look at number 33, it's called a scholarship question. Scholarship questions are usually tougher than I'm going to ask. Those of you that are shooting for your 100% and are nerdy, you can try these. But so I'm not going to cross it out. I'll put a star next to it. That's my way of saying, that one's optional. When I go through your package, I'm not going to be looking for that particular thing. Okay? You can cross out 34. You can cross out 35. 36, you can put a star next to. It's a scholarship question. I crossed out 35. 36, put a star next to. But then I stuck a bunch more cliff at an angle because I didn't think this document had enough practice. So 37 is good. But you can skip finding the impact velocity for 38. 39 is good. And then remember, I've got, not only do I have the answers attached, there's a full handwritten showing all my steps answer key. I also have for you a take-home quiz. This is your official homework for next class because we're done. I'm pressing pause. So Tuesday, tomorrow afternoon, I see you. Here's a take-home quiz.